Hi students, welcome to Kribai Tuition Center. Now we will see exercise number 6.2, question number 1. Find the angle of elevation of the top of a tower from a point on the ground which is 30 meter away from the foot of the tower of height 10√3 meters. So now draw the diagram for this. Find the angle of elevation of the top of the tower from a point on the ground. So there is a point on the ground. This is the tower. So you need to find theta. Find the angle of elevation of the top of the tower from a point on the ground which is 30 meter away from the foot of the tower. So that is 30 meters away from the foot of the tower of height 10√3 meters. So the height of the tower is 10√3 meters. Now name it as A, B, C. Now you need to find theta. You have the opposite value and the adjacent value. So what angle you will take? Tan theta. Tan theta is equal to opposite by adjacent. So tan theta is equal to opposite is 10√3 divided by 30. Root 3 divided by 3 is nothing but root 3 into root 3. So you will get 1 by root 3. So, tan theta is equal to 1 by root 3. Theta is equal to tan inverse of 1 by root 3. So in the table you all know 0, 1 by root 3, 1, root 3, infinity. These are the tan theta values 0, 30, 45, 60 and 90. So here you have 30 degrees. So theta is equal to 30 degrees is the answer. So the angle of elevation is 30 degrees. Now we will see second sum in exercise number 6.2. A road is flanked on either side by continuous rows of houses of height 4√3 meters with no space in between them. A pedestrian is standing on the median of the road facing a row house. The angle of the elevation from the pedestrian to the top of the house is 30 degrees. Find the width of the road. So now let this be the road. So he is standing in the middle and he is watching the top of the house. So this is 30 degrees. Now the height of the building is 4√3 meters. Now see, since the object is is at a longer distance, we will always take the object as a single point. Okay. Because the distances are so far, we will take the object as a single point. Now from here, he is viewing the top of the building which is 4√3 meters. So you need to find this adjacent value, and if you multiply by 2, you will get the width of the road. Now see, this is theta, so this is opposite and this is adjacent value. So what angle you will use? Tan theta. So tan theta is equal to opposite by adjacent. Now you want the adjacent value. So tan 30 is equal to opposite is 4√3 divided by adjacent. Tan 30 value is 1 by root 3 divided by adjacent. Now, adjacent is equal to 4√3 into root 3. Root 3 into root 3 is 3. So 4 3s are 12 meters. So the adjacent side is 12 meters. Therefore, the width of the road is 2 into 12, which is equal to 24 meters. We will see third sum in exercise number 6.2. To a man standing outside his house, the angles of elevation of the top and bottom of a window are 60 degrees and 45 degrees respectively. If the height of the man is 180 centimeter and if he is 5 meters away from the wall, what is the height of the window? Now let us draw a diagram. To a man standing outside his house, the angle of elevation of top and bottom of the window are 60 degrees and 45 degrees. So this is house. Let this be the window. He is standing 5 meters away. The angle of elevation of the top and bottom of the window is 60 degrees and 45 degrees respectively. So this is 60 degrees, this is 45 degrees. If the height of the man is 180 centimeters. So 180 centimeter. Find the height of the window. So now let us not consider this. This is not required for us. Only from here we are going to take it as two triangles now. This is I. We will name this now A, B, C, D. Now we need to find what? CD is equal to what? That is the height of the window. Now take it as two separate triangles. 60 degrees. So A, B, D. Next triangle. 45 degrees. A, B, C. Now see, we need to find the length of BD and length of BC. If we subtract, BD minus BC will give you the length CD. See, this is BD and this is BC. Now, if both these get subtracted, you will get the length CD. Here you have 5 meters, here also 5 meters. Now this is the angle theta. So this is opposite and this is adjacent. So what angle we have with opposite and adjacent? Tan theta. So tan 60 degrees is equal to opposite by, tan theta is equal to opposite by adjacent. Tan 60 degrees is equal to dB by 5. So dB is equal to 5 into tan 60. What is tan 60 value? 0, 1 by root 3, 1, root 3, infinity. So 30, 45, 60. 60 is root 3, which is equal to 5 root 3 meters. This unit is very important. Now here also we are going to take tan theta. So tan 45 degrees is equal to BC by 5. BC is equal to 5 into tan 45 value is 1. So 5 ones are 5 meters. So BC is equal to 5 meters and dB is equal to 5 root 3 meters. Height of the window is BD minus BC. So BD is 5 root 3 minus 5. Take 5 common out, you will have root 3 minus 1. What is the root 3 value? 1.732. This minus this 0.732. Now 3 are 15, 16, 7 are 35, 36, 3. So after 3 digits keep the point. So equal to 3.6, 3.66 meters. So the length of the height of the window is 3.66 meters. Now we will see fourth sum in exercise number 6.2. A statue 1.6 meter tall stands on the top of a pedestal. From a point on the ground, the angle of elevation of the top of the statue is 60 degrees. And from the same point, the angle of elevation of the top of the pedestal is 40 degrees. Find the height of the pedestal. And in brackets, they have given you the tan 40 degree value and root 3 value. A statue 1.6 meter tall stands on top of a pedestal. Now what is pedestal? The base on which the statue stands. Now you all have heard of pedestal fans. So some support is there and on the top the fan will be there. So naturally the pedestal is, let this be the pedestal, and over this the statue is kept. Okay. So now we need to find the height of this pedestal. A statue is 1.6 meter tall. So the statue is 1.6 meter tall. Stands on the top of a pedestal. From a point on the ground, the angle of elevation of the top of the statue is 60 degrees. And from the same point, the angle of elevation of the top of the pedestal is 40 degrees. So the top of the pedestal is 40 degrees. The top of the statue is 60 degrees. Now, find the height of the pedestal. So here we have 1.6 meters. We need to find this value. Now let us name it A, B, C and D. Now take it as two separate triangles. A, B and C. A, B and D. Now we have here 1.6 plus, let the height of the pedestal be P. We will keep this length as P. So this is 1.6 plus P. We don't know this value also. Let this be X. Let A be X. This is P. We have the opposite and the adjacent. So we will take tan theta. Tan 40 degrees is equal to opposite is P and adjacent is X. Now X is equal to P divided by tan 40 value they have given in the question 0.8391. In this triangle also we will find out X. So here tan 60 degrees is equal to opposite is 1.6 plus P by X. Now X is equal to 1.6 plus P divided by, what is tan 60 value? Root 3. Here also you have X and here also you have X. Now we are going to equate this X. Now we have equated it. Now we need to find the value of P. So cross multiply, root 3 P is equal to 0.8391 into 1.6 plus root 3p is equal to 0.8391 into 1.6 plus 0.8391 into p. First term with the first term and first term with the second term. Now take this p this side. So root 3 value is 1.732. P minus 0.8391p is equal to 0.8391 into 1.6. Okay, let it be here. We will solve it in the last. Now subtract these two things. We will get 8391 into 1.6. P is equal to 0.8391 into 1.6 divided by 0.8929. Now we will take off these 2 points. 16 divided by 4, 10. Eight three nine one into 16. 6 ones are 6, 6 nines are 54, 4, 6 threes are 18, 8 6 are 48, 49. So 134256 divided by 89290. Now we'll divide these two things. 449660. am not proceeding on with this. We will stop with this. So which is equal to 1.5 meters. So the height of the pedestal is 1.5 meters. Next, fifth sum in exercise number 6.2. A flagpole h meters is on the top of a hemispherical dome of radius r meters. A man is standing 7 meters away from the dome, seeing the top of the pole at an angle 45 degrees and moving 5 meters away from the dome and seeing the bottom of the pole at an angle 30 degrees. Find the height of the pole, radius of the dome. So now we draw the diagram. A flagpole h meters is on the top of a hemispherical dome. So a flagpole. A man is standing 7 meters away from the dome. Seeing the top of the pole at an angle 45 degrees. And moving 5 meters away from the dome and seeing the bottom of the pole at an angle 30 degrees. So again he is moving 5 meters away and seeing the bottom of the dome 30 degrees. Find the height of the pole. So this h is equal to what? And find the radius of the dome. So r is equal to 1. So we need to find these two values. I'll read the question again. A flagpole h meters is on the top of a hemispherical dome of radius r meters. A man is standing 7 meters away from the dome, seeing the top of the pole at an angle 45 degrees and moving 5 meters away from the dome and seeing the bottom of the pole at an angle 30 degrees. Find the height of the pole, and second is find the radius of the dome. Root 3 value they have given 1.732. Now we need to find. See, first let us take it as two triangles. Degrees. So this will be r plus 7 plus 5. So r plus 12. This value we don't know, and this is r. This is also radius, so we'll take this as r. Oh, hypotenuse. Now take the next triangle. This is 45 degrees. The length is r plus 7 meters. Here it is r. Okay. R plus h. Because here we are taking r plus h. So r plus 7, the angle is 45 degrees. Now we will equate. We have opposite and adjacent. So we will take tan theta. Tan theta is equal to opposite by adjacent. Tan 30 degrees is equal to r by r plus 12. 1 by root 3 is equal to r by r plus 12. Here also tan 45 degrees is equal to opposite is r plus h by r plus 7. So tan 45 value is 1. 1 is equal to r plus h by r plus 7. Take this here. R plus 7 is equal to r plus h. This r and this r, let us not cancel like this. R plus 7 is equal to r plus h. So bring this r this side. So r minus r is equal to r minus r plus 7 is equal to h. So h is equal to 7 meters. So the height of the flagpole is 7 meters. So we have got here now r plus 7. This is also r plus 7 and this is also r plus 7. Now come here. Here we have 1 by root 3 is equal to r by r plus 12. Now cross multiply. R plus 12 is equal to root 3 into r. Bring the r together. So root 3r minus r is equal to 12. So root 3 value is 1.732. R minus r is equal to 12. So 0.732 into r is equal to 12. Zero 0.732 into r is equal to 12. R is equal to 12 divided by 0.732. So let us divide now. We'll get 12 into 732. So 2 6 are 12. 3 are 6, 2 6 are 12. 6 are 12. 6 6 are 36. 6 1 7. So 1000 divided by 61. Divide 1000 by 61. Nine minus 6 is 3. 90. So let us stop with this. So which is equal to 16.3 meters. So the radius of the hemisphere is 16.3 meters and the height of the flagpole is 7 meters. Next, sixth sum in exercise number 6.2. The top of a 15-meter high tower makes an angle of elevation of 60 degrees with the bottom of an electronic pole and angle of elevation of 30 degrees with the top of the pole. What is the height of the electric pole? So now the height of the tower is 15 meters. High tower makes an angle of elevation of 60 degrees with the bottom of an electron. And angle of elevation of 30 degrees with the top of the pole. What is the height of the electric pole? So, it's equal to what? Now let us name this now A, B, C and D. Now take it as two triangles. 60 degrees. This is 15. B, C. 30 degrees. This will be A, E, D. So this naming you can give it by yourself according to your convenience. So A, E, D. This pulley is 15. Now we will find BC. BC is equal to ED. So we will equate that here. This is opposite and this is adjacent. So what you will take? Tan theta. Tan theta is equal to opposite by adjacent. So tan 60 degrees is equal to opposite is 15 by BC. Tan 60 value is √3 BC. BC is equal to 15 divided by √3. Since we cannot have √3 in the end, we will do it like this. 15 into √3 divided by 3. 3 5s are 15. So 5 √3 meters. So what is the length of BC? 5 √3 meters. Therefore BC is equal to ED is equal to 5 √3 meters. If this is 5 √3, this is 5 √3. Both are parallel lines. 5 √3 meters. Now we need to find the opposite value. So we will write this as, we need the height of the h of the pole. So this is h and this is 15 minus h. Total is 15 meters. So totally it is 15 meters. Here you have the h value. So here also h. So this will be 15 minus h. So AE value is 15 minus h. Can you all understand this part? The whole thing is 15 meters and this is h. So this will be 15 minus h. Take it here. AE is equal to 15 minus h. Now take tan theta. Tan 30 degrees is equal to opposite by adjacent, 15 minus h by 5 √3. So tan 30 value is 1 by √3. 1 by √3 is equal to 15 minus h by 5 √3. Now cross multiply. 5 √3 divided by √3 is equal to 15 minus h. √3 and √3 gets cancelled. Continuing it here. 5 is equal to 15 minus h. So h is equal to 15 minus 5. H is equal to 10 meters. So the height of the electric pole is 10 meters. Next, seventh sum in exercise number 6.2. A vertical pole fixed to the ground is divided in the ratio 1:9 by a mark on it, with lower part shorter than the upper part. If the two parts subtend equal angles at the place on the ground, 25 meters away from the base of the pole, what is the height of the pole? A vertical pole is fixed to the ground. Fixed to the ground is divided in the ratio 1:9. So this is 1 and this is 9 parts. This is 1 part and this is 9 parts. So 1:9 ratio it is divided by a mark on it, with the lower part shorter than the upper part. So the lower part is shorter than the upper part. If the two parts subtend equal angles at a place on the ground. At some place on the ground, that is 25 meters away from the base of the pole. So this angle and this angle is equal. What is the height of the pole? So this is going to be alpha, then this is also going to be alpha. So here a small correction. A subtends equal angles. So if this is alpha, this is also going to be alpha. This will be the angle bisector. The two parts subtend equal angles on the point of the ground. If the two parts obtain equal angles at a place on the ground 25 meters away from the base of the pole, what is the height of the pole? So now this pole height we need. So let this pole height be h. Okay. So this is in the ratio 1:9. So we'll write it as 1p and 9p. 1p plus 9p is equal to h, height of the pole. And we need to find the angles. We'll put it as theta itself. This is also theta and this is also theta. We need to find the theta is equal to what and h is equal to what. Now, split it into two triangles and take it. Name these triangles A, B, C and D. Now take D, B, C. So this is theta, this is P and this is 25. Height h 25. This is going to be theta plus theta 2 theta. Now opposite and adjacent values are there, so we will take tan theta. Tan theta is equal to opposite by adjacent. Here also tan 2 theta is equal to opposite by adjacent. This h is nothing but 9p plus 1p, right? So we will take it as p itself. Here it will be 9p plus 1p, which is equal to 10p. So 10p by 25. Here also tan theta is equal to p by 25. Tan 2 theta is equal to 10p by 25. Here you need to apply the formula for tan 2 theta. That is nothing but 2 tan theta divided by 1 minus tan square theta. Actually this formula is coming for you in 11th standard only, but for this one particular sum we are using it. So you need to remember this formula by yourself. Tan 2 theta is equal to 2 tan theta divided by 1 minus tan square theta, which is equal to 10p by 25. Now substituting this tan theta value here, so it will be 2 into p by 25 divided by 1 minus p by 25, the whole square is equal to 10p by 25. P by 25 divided by 1 minus p square divided by 625. 25 into 25 is 625. Is equal to 10p by 25. Take LCM here. 2p by 25 divided by 625 minus p square divided by 625 is equal to 10p by 25. Two p by 25 into 625 divided by 625 minus p square is equal to 10p by 25. 1 into 25, 625. It's 50. 50 10p divided by 625 minus p square is equal to 10p by 25. Now cross multiply. 25 into 50p is equal to 10p into 625 minus p square. This 10 bring it here. So 25 to 50p divided by 10p is equal to 625 minus p square. P and p gets cancelled. 10 5s are 50. So 5 5s are 25. 125 is equal to 625 minus p square. P square is equal to 625 minus 125. This is 27. P square is equal to 500. So P is equal to root of 500. For root 500, I am taking the LCM and finding it out. Always for LCM, take only prime numbers here. So which is equal to 5 and 2. 5 square into 2 square, the whole root. This square and root gets cancelled, so 5 2s are 10. 10 root 5. So the value of P is 10 root 5. We need to find the height of the pole. So first we will find 9p. So h is equal to 9p plus 1p, that is nothing but 10p, right? 10p. So h is equal to 10 into 10 root 5. So 100 root 5 meters. So the height of the flagpole is 100 root 5 meters. Remember, whenever ratio is given, you need to take a constant here. I have taken it as p. You can take any constant like x or y or p or s, t, anything, in any constant you can use it. Whenever ratio comes, always we should use it as a constant. Now this is the height of the flagpole, and that is split in the ratio 1p and 9p. That is 1 part of something and 9 part. So both the things when we add, we will get the height. Finally, we have got the height of the flagpole is 100 root 5 meters. Next, 8th sum in exercise number 6.2. A traveler approaches a mountain on highway. He measures the angle of elevation to the peak at each milestone. At 2 consecutive milestones, the angles measured are 4 degrees and 8 degrees. What is the height of the peak if the distance between 2 consecutive milestones is 1 mile? Now they have given you the value for tan 4 degrees and tan 8 degrees. A traveler approaches a mountain on the highway. He measures the angle of elevation to the peak at each milestone. So, using a highway, he is traveling to reach the top of the mountain. Approaches a mountain on the highway. He measures the peak at each milestone. So the first milestone, he measures the angle at each milestone. Let the 2 milestones be this. At two consecutive milestones, the angles measured are 4 degrees and 8 degrees. And as he approaches near, it will be 8 degrees. It is 4 degrees, and as it approaches to the next milestone, it is 8 degrees. What is the height of the peak if the distance between two consecutive milestones is 1 mile? So this is 1 mile. What is the height of the peak? Now we'll take the test triangle and we'll name it. This is 1 mile. Okay. We will take the first triangle. This is H. So this is 1 plus, let the length of CD be x. So 1 plus x. A, B and D. Now take this triangle. 8 degrees. H by x. A, C, D. Now we have opposite and adjacent. So what we will take? Tan theta. Opposite by adjacent. So tan 4 degrees is equal to h by 1 plus x. Here tan 8 degrees is equal to h by x. Here h by 1 plus x and here h by x. Now we have the value of tan 4 degrees is 0.0699 is equal to h by 1 plus x. Here 0.1405 is equal to h by x. Now we have got these two equations. We will find h and we will equate it. Here h is equal to 0.0699 into 1 plus x. Here h is equal to 0.1405 into x. Now here also you have h and here also h. So we will equate these two things. 0.0699 into 1 plus x. See here, they are asking you to find the height of the peak. So let us find out the value of x and equate and directly find the value of h. Instead of doing like this and finding the value of x and then substituting and finding the value of h, I am just finding out the value for x. So 1 plus x is equal to h by 0.0699. So x is equal to h by 0.0699 minus 1. Here x is equal to h by 0.1405. Now let us equate this x. Here also x, here also x. So we will equate it. H by 0.0699 minus 1 is equal to h by 0.1405. So here take LCM, h minus 0.0619 divided by 699 is equal to h by 0.1405. am now doing the calculations. H minus 0.0699 is equal to, I am bringing this here, cross multiplying H by 0.140. Now we will remove the point 699 by 140. Here also after 4 digits you have the point, here 4 points. So we are cancelling it. H. Now so I am just topping it with 2 decimal points. Bring the H together. One minus T1. Minus 3, 6. Six ones are 6, 6 fives are 30. 540. So again 9 ones are 9. So 13.69. Since divided by 100 is there, you will bring the point, so it will become 0.1369, so which is approximately equal to 0.14 mile. So the height of the peak is 0.14 mile.